Hello and welcome to my channel. Well, today I'm gonna give you guys the good, the bad, the ugly. The 7.3 engine. People say it's super reliable. It has no problems. There's so much false information out there. People say there is no cam phasers or cam phaser. It's a push rod, a simple engine. Well, let me show you how reliable this engine. You know what I mean? People say there is no timing chain. Somehow the camshaft rotates on its own. They built 7.3 gas engine. 7.3 gas engine, you know. No cam phaser. What is a variable cam timing improves engine efficiency? Well, Ford says it has it. So where do people get idea that it doesn't have a cam phaser? I don't know where the people get ideas. But let me show you something else. Before I'll show you three major design flaws with this engine. Three major design flaws. So let me show you the reliability of these engines. So what do you see here? 2020 7.3 gas engine. Well, it's a 7.3, so supposed to be a reliable engine, right? Well, let me show you how reliable these engines are. This is a brand new engine. 48,000 miles, short block replace. Engine removed to complete repair. So what happened? Or they not changing the oil? I do not know. The fact is, it's a low mileage, it was still under warranty, and the engine failed. So does that make the engine reliable? I guess to some people that makes the engine reliable. Some say, I heard one person said they, third transmission and the truck doesn't even have 100,000 miles. They say that's reliable. Though, if that's your way of thinking, if that's your reliability, keep replacing engines or repairing transmissions or replacing, hey man, it's your choice. To me, I like when you don't have to replace the engines or transmissions. You drive for 500,000 miles and you don't replace anything except just the maintenance items like spark plugs, coils, water pump, glow plugs, or things like that. That's I consider a reliable engine, but not when you have to take the engine apart. There is another engine, 7.3, 16 valve gas engine. Another certified. Let me show you. Another engine failed. A long block replaced at 74,000. Different dealer. That one's at 48. This one's 74. So how reliable are those engines? In this video, I'm gonna show you guys how to make those engines reliable, even if they have a design problems. But I'm gonna show you the design flaws first, so you are aware of, so you can know about them and do something about it to prevent those things from becoming problematic and costing you thousands of dollars. Let me show you something else on those 7.3. There's another one, third one, 7.3 16 valve, another certified. We're not showing you 20, 30 years old trucks here. We're talking about a new truck that it's been, has problems. Look at this, 68,000 internal transmission repaired. How did that happen? Well, it failed. So I can show you right now, that these trucks are either they were abused. We don't know exactly the history, but we know that things failed at the warranty basically. First engine failed at 48, next one at 78. So a couple years old truck and there is already engine problem. So let me show you the details about this engine. As you can see, it has cam phasers or cam phaser, as Ford states right here. Oh, right here, variable cam timing improves. So it has a cam phaser, as Ford says. You know what I mean? Max torque at 4,000 RPM, and then it's dropping after that. Horsepower max at 5,500. So the sweet spot is about 45, where you have kind of good amount of torque and good amount of horsepower. Because after that you have horsepower, but you generated just heat. You don't have the torque. Engine has to work harder. That's the reason I recommend people don't push past design torque. After that, torque drops, you have more horsepower, but horsepower generates more heat, so you're not really gaining much. Engine just screaming, trying to keep up with it. Lower the speed slowly but surely. Go slower, but at least you're not gonna be suffocating the engine. on the positive side, the 7.3 has a very nice oil ring, oil control ring or oil scraping ring that allows the oil to remove the oil from the walls. This is very nice design. Ford is not doing this type of design on their EcoBoost engines or their 5.0s, 5.0. This is old school technology, which is I'm happy to see the Ford actually implemented on the new cars, or actually on the new engine, because majority of car manufacturers don't use this type of design. They abandoned that used to be a standard in 90s, early 2000s, and then everyone dumped this somewhere around 2007, 2008, and went up to different design that creates the more problem. It's smaller, lighter, engine revs up faster, but consumes oil. Problem with oil consumption becomes. And here's another beautiful picture of this 7.3 engine. People say it has no timing chain. What do you see here? Has no cam phasers. What do you see here? Here's a cam phaser. Here's your timing chain. It has two chains. There's a timing chain and there is a oil pump chain that drives it. Look at this plastic guides, you know what I mean? This is, yeah, this could be problematic, and I will explain to you, you know what I mean, how you can avoid. Cam phaser, 5.4, 3.5 engines, oh, they're known. Is every single 5.4 and 3.5 has a cam phaser issues? No. There are trucks with 200,000 engines never been opened up. And now, you know why? Stay till the end and you'll learn why. I want you to notice something. You see this right here? The oil pump of this engine, that's the problem. First problem, the design problem, the cam phaser. This is a problematic part on Ford, but not on every single engine. And the reason why? Because people do not follow. People that don't have problem with this, with the cam phaser, are the ones that use high quality oil and don't follow Ford recommendations. They don't have the problem. People that use cheap oils and follow Ford recommendations for intervals, they have engine problems. You can avoid this. You can be one of those 1% of people that will get 200,000 easy out of this engine without cam phaser problems. Or you can be one of those people that will have the problems with the engine if you follow Ford recommendations for the oil change and the oil quality. Look at this shaft. There's a shiny shaft. So the oil is in the back. Ford decided to use world dumbest engineering. Instead of putting a pump here, how about we put a shaft? Why might as well put a shaft? We'll put the oil pump all the way in the back of the truck, by the bumper, run the pipe into the oil pan. This makes no sense. Well, apparently Ford engineers think, we'll do something different. Well, yeah, they did something different. But I'll tell you what, if you use low quality oils, these portions here will wear out, you're going to have vibration, and your engine will fail fast. So it's your choice what products to use. You can ask for recommendations, you can do research. So there you go. Second problem. First problem, cam phaser. Second problem, the shaft. No one does. Absolutely no one does in the whole entire industry. This is the first of its kind. This is the dumbest thing of its kind. Makes no sense. If you want to put the oil pump in the back, they drive it from the back. There is ways you can do it. Don't drive it with a shaft, like it looks like a drive shaft to me. That's just insanity. This is the dumbest thing that will fail. Here is a better picture of this beautiful Fomoco cam phaser. So right here, this is a problematic part. If you follow Ford recommendation and use okay oil, cheap oil, don't use high quality oil, you're gonna have problems with that. You're gonna have problems with timing chain tensioner too, because it will get clogged up. It will cause the chain to fail, will cause the chain to stretch due to low quality oil, and then all kind of engine noise, all kind of vibrations. Oh, sweet. The Ford technicians love those things when they break down, because they keeps them busy, keeps their dealers love those problematic engines and problems, because it brings the money to the shop. And the third design flaw, this cut right here. This is the major no flaw, major no go. I want you guys to notice the right side thickness and the left side head gaskets. On their different engine. Actually, this This is the EcoBoost. You see, same design, and those engines are known for head gasket issues before even reaching 100,000 miles. It's a well-known problem. It's a design flaw, and this same thing design flaw. How to avoid this head gasket problem on 7.3 from failing? First, allow the engine to warm up to operating temperature before you load. Apply a load to it. Start loading the engine. Start revving it up. Second, allow engine to cool off after driving hard or pulling or towing, whatever you do. You know what I mean? Allow it to cool off. And the problem is you have uneven distances. The common place where the head gaskets fail is between the cylinders. It's not here somewhere because you have enough material. Not enough material here, not enough surface area. These are the spots where they fail. That's why the EcoBoost 4 cylinders, they're known for this problem. It just, if you search, there's YouTubers, there are people making killing. They're making money off thousands of dollars in repairs. Either they replace the head gaskets or they swap the engines because they keep failing. 7.3 is not an exception, unless you follow those steps that I mentioned earlier. So that's a third design flaw. Because Ford does not use this type of design on any of their engines. Nowhere. Absolutely. Absolutely nowhere. Because this makes no sense. This is 7.3. I want you guys to notice. 7.3 does not have timing chain. It has gears. It's a solid, reliable engine, 7.3. It's not the most powerful, but it's the best reliable engine Ford ever made. Let me show you something else. Brand new engine from Ford for 6.7 is $10K. It's not cheap. If you can afford $70,000 truck, what's 10,000? That's a drop in the bucket compared to 70, 80,000. And notice this. See how 6.7? You see the distance between the cylinders? You see how much surface area is there? There is no cut in the middle. Well, if the 6.7 is designed without a cut, why 7.3 has a cut? Well, it's designed specifically to fail. It's designed, you know what I mean? There's things they do. I used to work for a company that they were training us how to install a simple software, but 2-3 pages long instruction to install it. And I asked the guy who was training, why is it so complex? Can it be simpler? He's like, yes. So the customers cannot do it themselves, so we can make more money. So it was specifically designed installation of the software. So you have to jump through all these hoops to install the software. So they cannot do it themselves. They will have to hire a company to install the software. And they were training us so they can send us as a field support techs, so we can install this type of software, and company can charge the customer big money. Same thing Ford does, and not just Ford, many OEM car manufacturers do. They design things with the purpose so it will fail prematurely, so it will fail before you can reach 100,000 miles. So it will fail so they can make money in repairs or engine replacements. On 6.7 is a solid engine. It's a solid engine. It's a reliable engine. It has a few flaws due to assembly. People are gonna say CP4. Well, you can get $500,000 out of CP4 and injectors. I know people got $500,000 with original injectors and CP4. The key to that is high quality fuel additive, not just a fuel additive, high quality. Remember, garbage in, garbage out. High quality in, high quality out. So that's a 6.7, you know what I mean? There is no cut. Look how much space in. There is a good surface area. So that's why those engines are not known for head gaskets unless people, increase massive, pushing a lot of power out of these engines, do crazy stuff. And here is another picture of 6.7. There is no timing chain. That's why those engines, they last forever basically. You'll never have a chain because they have gears. If they would have done it on 7 3 gears, would have been much better design. Here is a better picture. Look at this chain, and look at this oil pump with this drive shaft here. This shaft, it's a joke. You know what I mean? This is a joke. Put in a shaft to drive the oil pump. You couldn't drive this from the back. You can put a gear, variable pressure, variable speed oil pump. You know what this is? What reminds me of? This is how designed the power steering pumps. This is definitely not a best design, because having those things, flappers, whatever you want to call it, sticking out, and if you don't have always clean, high quality oil, it will generate so much oil. This oil will be circulated to the bearings, and bearings will fail prematurely. I can see this engine being as problematic as, I don't know, worse than 5.4, worse than 6.0 with this type of design for people that don't change their oils. That people that run quality oils, you know, I can see those engines lasting a long time, with the exception for the head gasket. So to summarize everything is, if you want to have a reliable engine, you have to look at the design. You know, I always say history repeats itself. If you want to know the future of this engine, look at the history of previous Ford's engines. Some things, cam phasers, that are preventable, that can be prevented by, you know, quality oils prevents cam phaser from wearing out. Same thing, high quality oil will prevent oil pump from wearing out and causing all kind of issues. Head gasket, you can prevent from failing sooner by allowing the engine to warm up and allowing the engine to cool off without turning it off, shutting the engine off. Following those few simple steps will guarantee you a long life out of this engine. Would I personally buy this engine? Truck with this engine? Absolutely not. Prefer 6.2. 6.2, I prefer old 7.3 diesel. That's my, you know, if I go with Ford, that's the way to go. If it's a, you know what I mean, I would rather have less powerful but simple and more reliable engine than, because power equals trouble. No matter where you look, no matter from which angle you look, no matter what areas you look, where there's a power, there is a trouble. So, I want to thank you for watching this video. If you have questions, ask me in the comments section.